let's see.
How do you figure out what the quadrant is? Because they obviously don't tell you right away.
No, they don't. So let's go ahead and talk through that so that you can get working on it while I'm doing attendance. So I think that's a good question to just jump straight into. So when we're looking at our cosine, our alpha triangle, it says that the cosine of alpha is negative. It's negative 4/5. So I'm going to start drawing my little 4 quadrants, and I'm thinking, okay, where is my cosine negative? Cosine we associate with our x value. So it's not in quadrant 1 and quadrant 4 where it would be negative. It's either going to be quadrant 2 or quadrant 3 because the cosine is negative. Okay. Then it says the sine of alpha is greater than 0. And what does it mean to be greater than 0? It just means that it's positive. That's how we say that it's positive, is by saying that it's greater than 0. So in those 2 quadrants, Shay, which one would have a sign that's positive?
It would be quadrant 2.
Right, because we think of sine as our y values, and our y values are negative in quadrant 3. So it's going to be in quadrant 2, just like you said. And so we would draw our radius coming out from the origin, drop in altitude perpendicular to the x-axis, and then we would start dropping our values in. We know cosine is x over r, so my x value is 4, and my r value is 5. And which one of those gets the negative? Shay, which one gets the negative? The x or the r?
The 4.
Right, which is our x value for 2 reasons. One, because you can see the x is negative in quadrant 2, okay? And because we know our radius is always positive, okay? So that's my alpha triangle, and once we know 2 sides, we can find the third. This one, it's easy peasy to find the third side because this is a Pythagorean triple. This is a 3, 4, 5 triangle. And should that y be positive or negative in second quadrant?
It would be positive.
Exactly. Okay. So then you have your 3 sides of, good morning, Valerie. So nice to see you. She's like, not for long, Miss Weaver. That's okay too. It's still nice to see you about that. That's okay. That's okay. It was nice to see you for a brief second. Okay, so that once we have all 3 sides, we can find any of the trig values that we need when we're plugging into the formulas. Okay, so let's run through getting our beta triangle drawn, and then we'll be ready to go. So it says the tangent of beta is positive. Tangent of beta is positive. Remember, tangent is y over x. And so there's 2 ways to make a positive. Either they are both positive, or a negative over a negative will also cancel each other out to become positive. So when we're thinking about where our beta triangle goes, we know x and y are either both positive, which would be quadrant 1, or they're both negative, which would be quadrant 3. Okay, so I can eliminate 2 and 4 because 2 and 4 have tangents that are negative. Okay, and we see here that our tangent has to be positive. Questions about that from anyone? Okay, so we've got 2 quadrants as possibilities, and then it tells us that our cosine of beta is less than 0. If greater than 0 means positive, what does less than 0 mean?
Negative.
Negative. So which of those 2 quadrants has a negative cosine? Well, it's not quadrant 1. Everything's positive in quadrant 1. So it's got to be quadrant 3 where my x and y are negative. Okay, so let's be careful here when we're putting our numbers in our triangle. Let's go ahead and draw our triangle in quadrant 3. Undo that. Okay, so I'm going to draw my radius coming out from the origin, drop in altitude perpendicular to the x-axis. And I know my tangent is y over x, so my y value is 7, and my x value is 24. But you need to be careful here, and this is where drawing it in the correct quadrant really helps. Okay, when we're in quadrant 3, we know both of those are negative. Both of those are negative. So I want to make sure and label that. My x is negative 24, and my y is negative 7. Okay. Now, this is also a Pythagorean triple, but I'm guessing most of you do have that one memorized. So we would still just do negative 24 squared plus negative 7 squared equals r squared. We undo a square with the square root. When we take the square root, we pick up the plus or minus option. Square root undoes the square and gives me regular r equals. We know we want the positive option because radius is always positive. If you put that in your calculator, you're going to get that your radius is 25. Okay, Okay, so X and Y are always negative in quadrant 3, but the radius is always positive. And if you plug in to get your tangent there, again, if you plugged in, you would get that the tangent of beta, this is my beta triangle, I'm going to go ahead and label it, is -7 over -24. And those negative cancel, and it does make +7 over 24, which is what they gave us. Okay? So now you've got your two triangles, so break out your formulas and start plugging in, and let's see how you do. Okay. Did that take care of you on that part, Shay?
Yeah, thank you.
All right, good luck. While I get attendance in, y'all knock those out. You're welcome. Okay, let's see how you guys are. So I did grade the Desmos activities last night, and I got them put in the grade book this morning. And so I was really proud of you guys. We had lots of hundreds, and I know that took some perseverance and some persistence. So I'm proud of you guys that did so well on that. I was shocked and a little worried about some of you. There's a few of you that didn't even attempt the second Desmos. I had one or two not do either Desmos, and I'm just wondering how you're thinking you're going to get through this test today, because that was our entire instruction for this unit was the discovery. And so I wanted to, kind of say a few more things about that, the way we approach this unit. So research shows that discovery learning leads to the deepest recall. So it's like the most effective form of learning, but that's because it requires more engagement from you. And so a few of you didn't like the fact that more was being asked from you, that you were having to be more engaged. And so, yeah, like I said, I had a couple people that just didn't do the Desmos. And so I'm really worried about you. But I wanted you to remember you're kind of in a transition point in your education. Your upper level, most of you are juniors and seniors. We do have some sophomores. But you guys are on your path to college, right? Like you're going to be taking calculus next year, and which is a collegiate level course, and all of that good stuff. And so like they talk about how they're no longer going to be spoon feeding you. And I have to say it's a ruder awakening than that. When I went to my first college calculus class, I was sitting in a stadium of 150 students, and the teacher was going, I was following him, and then something just didn't seem right, and I had a question, and I raised my hand, and he never took questions. And like, I was like defiant. I'm like, I'm going to leave my hand up. I'm like, I have a question about what you're doing. And he ignored it the entire block and finished class and left the lecture hall. Never took questions. Didn't take questions at all. So if you had questions in that math class, it was up to you to figure them out. You could come to office hours. You could go to math lab, because it was still in the early calc sequence where I could go to math lab and get help if I needed help there. But so, I mean, like that, like I said, for me was a rude awakening. I'm like, you're kidding me. You're not even going to take questions ever in math class. And then also, like your teacher, some of you are already dealing with this about having to learn in a second language. So because English is not your first language, that will happen to you like crazy in college. You'll have professors that speak all kinds of different languages, so they have accents and are harder to understand. And there's just going to be a lot of things that take your learning up to the next level, or take it up a notch, and more of the responsibility falls to you. So, this idea of needing to be able to read through something and think about it and try to figure out why that is, that's an essential skill as you move forward into college. You're going to have to read your textbooks, your math textbooks, and figure things out. And you're going to have to be able to look through answer keys, which you already kind of get to do, like in my, let's see, I got to get my right program name up there. In your in your Delta Math, like when they work through, they have examples, and you have to look through the work of the completed example, and you have to figure out what was going on there and how that worked. And so those are some of those skills. You've got to take ownership of your learning and be ready to do those things, okay? And so don't shy away when we give you a little more ownership of your learning. Don't shy away from that, even though that's not the way you're used to learning. Know that you're going to have to do a lot more independent learning moving forward. And so we need you to rise up and try that. Rise up and do it. Now, that being said, I had a few people tell me they spent 3 hours on the Desmos, and I don't want you spending 3 hours. Okay, if you're having trouble or struggling, I want you to come to class the next day, and I want you to ask questions, okay? But that was just Ms. Weaver's little 2 thoughts on what I saw from some of you this unit. And I hope you'll know that I have your best interest at heart, and I hope you'll kind of ponder and think on those things that I said, and maybe consider making a change in the way that you're approaching your assignments. Okay, so let's see how you did. Looking through, good. Okay, and remember to submit your response so that I can see it. So I'm only seeing responses from a few of you. So we do want you in the Pear Deck and working so we can see how you're doing. Okay, are there any of these that you guys would like to see worked out? It is just plugging into a formula. So I'm going to give you the correct answer so you can know if you're correct. And I'm happy to work any of them if you struggled with any of them and need to see them worked out. But otherwise, we'll just move on to our next problem. So on this one, for the sine of alpha minus beta, you should have gotten -4/5. For the cosine of alpha plus beta, you should have gotten 1/17/125. And for the tangent of alpha minus beta, you should have gotten -4/3. Okay, so anybody not get those or have questions about those?
Miss Weaver, I didn't get the cosine or the tangent one.
Okay, so let's look at those quickly. No problem. Let's run through them. Okay, so can you help me plug into the cosine formula, Shay? Or I guess I already had you help with one problem, so I'm not going to make you do a second one, so I'll help with this one. It's cosine of the first, cosine of the second. And when the words stay the same, the sign changes. So since this was plus, it's going to be minus, sine of the first, sine of the second. So I want to go find those cosine and sine values and plug them in. So the cosine of alpha they actually gave us, that's -4/5. And the sine of alpha is going to be y/r, or 3/5. The cosine of beta is going to be. You found it?
Sorry. So I did cosine A plus B, not a subtraction. Why do you have to change it?
Because I followed the formula. So if you look at your formula card, so plus is the top sign on the left. So you want to follow the top sign all the way through on the right. And the top sign on the right side of the equation, so on the left side of the equation, it's cosine of alpha plus or minus beta. On the right side of the equation, it's cosine alpha, cosine beta minus or plus sine alpha, sine beta. So the minus is on top on the right side of the equation. So we're using the top equation all the way through, the top sign all the way through.
If they were asking for cosine A minus B, would we use the plus then?
Yes, because we'd be using the bottom sign all the way through. That's right. And so you're either following the top sign all the way through or the bottom sign all the way through. Okay.
Okay, that makes a lot more sense.
Yeah.
I think I did the same thing on the tan one then.
Okay. So I'll let you try fixing that, Shay, then, and definitely when we're done, if you need me to come back to it, I can definitely come back to it. Did anybody else need to see any of these? Are we okay? I'm just going to go ahead and drop in those numbers just so you can make sure you've got your sine and cosine right. On our beta triangle, cosine is x/r, so that's going to be -24/25. And this is where you'll be in trouble if you didn't remember to make those negative in third quadrant, because this is where you'll get the wrong answer. Sine is y/r, or -7/25, okay? And then you can do that by hand or take it to a calculator. I'm going to do it by hand quickly. So 5 times 25, and what I love about these problems when you are working by hand is that they always end up with a common denominator. So I'm going to go ahead and start it with my common denominator of 125. 5 times 25 is 125. Negative times a negative is a positive. So that's going to be 80 plus 16 is 96. Minus a negative will make a positive 21. Okay, and that gives me the 117 over 125. There. Okay, and like I said, I'm happy to help with the other ones if anybody needs to see them. But me taking the ones that you want to see is another way to let you take ownership for your learning and to make sure that you're ready to that we're doing the things that you need to do during review time. Let me take a look at chat real quickly. Okay, if you guys have individual questions about your Desmos grades, let's get through the review part together, and then I'll be happy to look at that for you individually. You do want to look at your grades and review your grades. You should absolutely be an advocate for yourself on that, but I just don't want to keep everybody waiting while we look at that. So, and Nanya and Nicholas, if you guys are concerned about that, let's chat just as soon as we're done reviewing. Oh, can I do the tangent one? Sure can. So thanks, Sarah. Okay, so on this one for tangent, the formula for tangent, can you walk me through that, Sarah? What does the tangent formula look like for the tangent of the difference of two angles? Just give me that formula. We're going to start by just copying the formula and then plugging into it.
Okay, so the tangent of alpha, and in this case it would be minus the tangent of beta.
Right, because on the tangent formula, it has the same symbol in the numerator, and then
1 plus the tangent of alpha times the tangent of beta.
Perfect, and it has the opposite sign in the denominator. And I do have it memorized because I use it so much, but you don't have to have it memorized. If you look at the formula chart, you're going to see that's the correct symbol if you're following the bottom symbol all the way through. Okay, so we're going to do tangent of alpha minus tangent beta over 1 plus tangent alpha times tangent beta. Okay, and what is the tangent of alpha, Sarah?
3 over -4.
Right, so I'm going to move that negative to the numerator. It's just easier for me not to lose it. So I'm going to put -3/4 in both of those places. And the tangent of my beta triangle?
-7 over -24.
And those negatives cancel each other out, so it ends up being +7 over 24. And of course, they gave us that tangent, so we knew that as well. So that's going to be +7 over 24.
And then it's the same on the bottom.
Right. Okay, now to add or subtract fractions, you need a common denominator. So my common denominator in the numerator is going to be 24, which means I have to multiply this fraction by 6 over 6. So that's going to be -18 minus 7. Or if you want to just do that in your head, that would make -25. For space, I'm going to go ahead and combine that right here, but that's just -18 minus 7, so -25 over 24 in the numerator. Are you okay with that part, Sarah?
Yeah.
All right. In the denominator, we're going to need a common denominator as well, but we've got to multiply these fractions first, okay? So when I multiply 4 times 24, that's going to be 96 again, okay? And so if 96 is my common denominator, I'm going to turn 1 into a fraction by putting it over 1, and then I'm going to have to multiply it by 96 over 96 to get that common denominator. So what does 1 look like over a common denominator? It looks like 96 over 96. Okay, so that's 1 plus, what do we get when we do -3 times 7? That's going to be plus a -21 over 96. Okay, so take a look at that for a second. See if you can follow my algebra there. So I did -21 over 96 plus 96 over 96, which is 1. Okay, and so that's going to equal a little bit of room. Short on space here. So -25 over 24, and it's going to be divided by, that's going to be, what is that, 75? 75 over 96. And remember that when we need to divide by a fraction, we multiply by its reciprocal. Okay, so I'm going to multiply by 96 over 75. Okay, now 25 goes into 75 3 times. Okay, 3 goes into 96 32 times. 32 and 24 are both divisible by 8, so that goes in 4 times, and that goes in 3 times. So I get -4/3 as my final answer. Don't lose that negative floating over there. It's right there, okay? And so that's simplifying by hand. A lot of you, I know you have access to calculators because you're at home and you do have calculators. We still want you practicing your algebra skills and you're building your number sense by trying these by hand. 100%, I want you checking on the calculator. Okay, so definitely, you know, check yourself on the calculator, but let's also work on our skills a little bit because we do want to build our number sense and our skills. Okay. Did you find your mistake, Sarah?
Yeah, I think so.
Well, do you need help doing it on the calculator? This is kind of a complicated problem to put in the calculator. Do you want help plugging into the calculator?
Yeah.
Yeah, let's try that. Okay, so let's go ahead and look at that. So, let's jump forward to a clean slide so we can see it. Okay, that is a complicated expression. So let's make sure we can put it in the calculator correctly. So I'm going to need a big set of parentheses for my whole numerator. So inside that, I'm going to have -3/4. Okay, and so far so good. Scroll out of the fraction, minus, and then I'm going to start another parentheses for this fraction so that it puts it in a fraction, 7 over 24. Okay, scroll out of the denominator and close that fraction, and then close your whole numerator because that's your whole numerator. Now, when I do the fraction bar, it will pop up and put it in the, it'll put it all up in the numerator. Okay, and now I can start building my denominator. So then I'm going to do 1 plus, and I want parentheses, -3 divided by 4. Scroll out of the fraction and close the parentheses. Open parentheses, 7 divided by 24. Just double checking myself. Scroll out of the denominator and close that. Okay. Now remember, the calculator is going to give you a decimal approximation here, and we want exact answers. This little fraction symbol on the left side, you may not have realized what that was. That's a fraction bar with a space for a numerator and denominator. If you click on that, it'll toggle to exact form, and you'll get -4/3. Okay. So right there, you can toggle back and forth between decimal approximation and exact answer. And that's like always one of our favorite features about a calculator, right? Questions on that calculator part? How'd you do there, Sarah?
I got the same answer.
Okay, good. Okay, good. And because, like, guys, if you're having trouble with your calculator and don't know what you're doing wrong, you can screen share and I can troubleshoot with you. We can help you figure it out. You have to know how to use your calculator. Like I said, I would expect you to check your answers on the calculator. We don't want any mistakes there. Okay. All right, let's try another problem. Good. All right, so same idea here. We've got to draw our triangle because -4/5 is not a sign value we recognize from the unit circle. Okay, and then we're going to use our double angle formulas. So these do work a little bit differently. So I just want to make sure that you know how to read them and that you're okay plugging into them. So let's try that real quickly. It says sine theta is -4/5. Okay, what I'm interested when I'm trying to figure out what quadrants is what sign they are. So if my sign is negative, okay, that means my y value is negative. So it can't be quadrant 1 or quadrant 2. And then, oh, and this one actually tells us what quadrant it's in. It says theta is between 3 pi over 2, which is right here at 270, and 2 pi, which is right there. So if it's got to be between 3 pi over 2 and 2 pi, then we know it's exactly in that quadrant between 3 pi over 2 and 2 pi. So I'm going to draw my triangle. The sign is y/r. So my y value is 4, and it's going to get the negative because we're in fourth quadrant, and because the radius is always positive. So that's going to be -4, and my r value is going to be 5. This is a 3, 4, 5 triangle. My x is going to be +3 because x is positive in fourth quadrant. Okay, and that's my theta triangle. We only have one triangle here because we're doing double angles. So what's our formula for the sine of 2 theta? That's 2 sine theta cosine theta. Notice that I always start by writing the formula first, okay? It both helps you learn it and it helps you make sure that you're plugging into the correct formula, okay? So that's going to be 2 times the sine of theta times the cosine of theta. My sine of theta is the one they actually already gave us. That's -4/5. My cosine of theta is x over r, or 3/5. So I can multiply a whole number by a fraction by putting it over 1 to turn it into a fraction. Then it's numerator times numerator all the way across, and denominator times denominator all the way across. 2 times -4 is -8, times 3 is -24. 1 times 5 is 5, times 5 is 25. So -24/25 is the sine of 2 theta. Questions about that? All right, let's run through the other formulas real quickly. Remember, for the cosine of 2 theta, you have 3 choices in equations. There is not a right one to pick. All 3 will give you the correct answer. So there are no worries about cosine of 2 theta. Pick any of you want, and we'll get the correct answer. So can you pick one for us, Nicholas? Which formula for cosine of 2 theta do you want to use?
Can we use the one where we just square them?
So, like, read me the one you want to use.
Okay. Cosine cosine squared
Yes.
theta, and then minus sine squared theta.
Okay, sounds good. Okay, so remember, that means the cosine value will be squared. So when you're setting up your parentheses for that, that's parentheses squared minus the sine value will be squared. So we're going to go grab our cosine and sine values. We already know the sine value is -4/5. We just found the cosine value is 3/5. Okay. And now, of course, we could put that in the calculator, but we want to work on trying it by hand real quickly. To square means to multiply it by itself. So 3 times 3 is 9. 5 times 5 is 25. Minus -4 times -4 is +16. 5 times 5 is 25. 9/25 minus 16/25 is -7/25. Okay, for our cosine of 2 theta. So far, so good. So far, so good. Questions for me on that formula? Really, I wanted you to make sure you understand how to plug that in when you're squaring the sine or cosine value. Okay, so let's run through the tangent of 2 theta real quickly. So that formula is 2 tangent theta over 1 minus tangent squared theta. So when we're plugging in, it's going to be 2 times the tangent over 1 minus the tangent squared. Okay, so tangent is y over x. So if we look at our thing, we've got -4/3, so that's going to be -4/3. Plugging that in both positions. Remember, we said to multiply a whole number times a fraction. We're going to make the whole number a fraction by putting it over 1. And then it's numerator times numerator and denominator times denominator. So -8/3. In the denominator, I'm going to need a common denominator to subtract fractions, right? To subtract fractions, I'm going to need a common denominator. But I've got to do exponents first. So I have to square that number first. So -4 times -4 is +16. 3 times 3 is 9. So we need to subtract 16/9, okay? I'm doing this in one step just to save a little space, but that's that minus 16/9. The minus is from this minus sign here, not from squaring it. Squaring it, it was positive 16/9, but I'm going to subtract that from 1. So what does 1 look like over a common denominator of 9? It looks like 9/9. 9/9 is 1. Okay, if you need to see a few more steps, you can turn that into a fraction by putting it over 1. Then you'd have to multiply by 9/9 to make it a common denominator. I want you guys to just get the concept that anything over itself is 1. So if the denominator is 9 and we're trying to make 1, the numerator needs to be 9 to make 1, okay? All right, and so then we've got negative 8 over 3 divided by 9 minus 16 is negative 7 over 9. To divide by a fraction, we multiply by its reciprocal. So I'm going to flip that fraction, 9 over negative 7. I like to mark it out once I've flipped it so that I don't think I still have more to do. The negative on top cancels with the negative on bottom. 3 goes into 9 3 times. Numerator times numerator and denominator times denominator. 8 times 3 is 24 over 7. And my negatives canceled, so this is positive. Positive 24 over 7. Questions for me about that? Okay, hopefully watching me work through those. Okay, hopefully you can see how we need to work on building that fluidity in our computations. Okay, and if you'll practice this by hand and not just rely on the calculator, you'll build that same fluidity. Okay, we're going to get really good at our algebra skills and how to handle these complex fractions. Okay, let's try another one. And if I'm going too fast, let me know. I feel like I'm hitting a good pace, but if it's too fast, let me know. I'm happy to slow down. I'm happy to answer questions. Okay, so it says write the expression as one involving only sine theta and cosine theta. This is a problem that you might have seen on your study guide, that you might see on your test today. And it's really just knowing about how to correctly substitute with the formulas. And then, you know, really that's just it. This is just to see if you can substitute it. So here we have 3 expressions. They want them as just sine thetas or cosine thetas. The first one already is a sine theta, so it's actually good as it is. Okay, so when I'm looking at my answer choices, I don't need to change that first term. It's okay as just a plain sine theta. Okay, so those 3 options have it as a plain sine theta. Same thing on my end term. It already is a negative cosine theta, so it can stay. Oh, we have already eliminated this answer choice. Let me make it a big X so I don't waste time on it again. Okay, so this already is a negative cosine theta, and this is 2. We do not need to change it, and it would be incorrect to change it to 1 minus cosine squared. That's what cosine of 2 theta does, not what just regular cosine of theta does. Okay, now the middle term, that's the one that's cosine 2 theta. And if we want it to just be sines and cosines, a correct substitution there. Because the difference here is that we want just the regular thetas and not the 2 thetas. Right now, this one has a 2 theta. And so if I wanted to substitute there, we could use so is cosine 2 theta, check your formula card. Is it 2 sine theta cosine theta, or is it cosine squared theta minus 1? Okay, looking at that grouping, that last one is that negative cosine theta that we had here. Okay, so is that the correct substitution, or is this the correct substitution? What do you think? Okay, I know it's not this one. 2 sine theta cosine theta is for my sine 2 theta. So B is the correct answer there. Okay, so B is the correct answer. Okay, so that's just kind of, so I just wanted to show you one so you're not nervous when you see those kind of problems. It's really just seeing if you can use the formulas and substitute in expressions. Okay, now this is the part that I think is usually the hardest part of this unit, although a lot of you may say that complicated algebra is hard too. We're definitely taking it up a notch. But this is the part where it can just kind of feel like a struggle, like there's not one right way to work through it. And so let's see what we can do. Let's see if we can prove the following identities. So the first one says cosecant theta equals cotangent theta times secant theta. Now, when you're trying to prove an identity, you want to usually work the more complicated side and get it to equal the simpler side, okay? That's usually the easiest way to work. So when I look at this, I'm going to work the right side and see if I can get it equal to the left side. And as a rule, we only work one side of the equation, okay? And the reason we do that is so that we remember we cannot just like subtract something from both sides because we have not yet proven that this is true. Okay, so we usually work just one side of the equation to remind us that we don't know if this is true yet. And once we've proven that one side does equal the other, then we'll know it's true and can use it if we want to, okay? So one of our main strategies is to change everything to sine and cosine. So if I want to change cotangent theta in terms of sine and cosine, What is cotangent in terms of sine and cosine? Anybody? Anybody? For me, do you have it? Go ahead and tell me, Valerie.
Oh,
Sine and
that was
cosine.
me.
Okay.
Oh. Which
Anybody?
one am I answering with which
Um,
side?
No, go ahead.
The right side. What is cotangent in
Okay.
terms of sine and cosine?
It's cosine x over sine x.
Very nice. But I'm going to use theta instead of x because I'm going to use whatever variable they're using in the problem. Okay.
Okay.
So I'm going to go ahead and call it cosine theta over sine theta. So I remember co starts with co. As far as tangent and cotangent, remembering which one is which, I remember that co starts with co. So cotangent has cosine on top. Okay. And what about secant in terms of sine and cosine? Can you help me with that? Somebody else popped in. Sure, Shay, go ahead. No, you're fine.
I can do, but if someone else wants to do, they can.
Yeah, I couldn't see who else it was. Like I didn't catch it in time. So go ahead and tell me, Shay. I'll let you help me with this one.
Okay. Secant is 1 over cosine theta.
Okay, very nice. So as a first step, I just changed everything to sine and cosine. And then I want to see, is that helpful? Because sometimes it'll be helpful and sometimes it won't. Okay, it won't always be the correct approach. But you got to not sweat it. You've got an eraser for a reason. You just try it and see if it's helpful. Was that helpful to me? Yeah, it sure was. Because now I can see this simplifies algebraically. The cosine on top and the cosine on bottom cancel, and that gives me 1 over sine theta. And now I'm really smiling because what am I trying to prove that the right side equals? The left side, which is cosecant. And what do we know about cosecant and sine? They're reciprocals. So 1 over sine theta, that's just the reciprocal of sine theta, which is cosecant theta. So we did it. We did it. Okay, so I give myself smiley faces when I prove the identities. They can be a challenge. Okay, so when I get through those, I like to celebrate our successes. Okay, any questions about that? Okay, so let's try another one. So looking at this identity on the right side. Okay. Yes,
Yes.
Nicholas?
When I was writing that out, when I type it out on the test, the study guide, I just put cosecant equal theta equals cosecant theta. Is that the right way to write that out, or should it just be equals cosecant theta?
So if they're asking for you to verify an identity, then your work is the proof, okay? And so you have to show the steps in between. So on the multiple choice ones like this, they'll have all the steps in a row. That'll be this, which finally at the end equals the cosecant theta, which is what we're trying to prove. So if you were typing in all of your work for this problem, you would need to type in each step. Cotangent theta, secant theta equals cosine theta over sine theta times 1 over cosine theta, which equals 1 over sine theta, which equals cosecant theta, okay? If they just ask, sorry, what?
As long as we put the steps in, we're good.
Yeah. If it's just asking you for an equivalent expression, then any of those 3 expressions are equivalent, and you could list any of those, and those would be equivalent.
All right.
Okay.
Cool.
Because like on the Desmos, it asks for an equivalent expression. Any of those would be okay. All right. Okay, so let's try that right side. Anybody think they got this? Anyone want to try talking us through this?
I can try it.
Okay, Nicholas, let's do it. And which side are we working, left or right side?
The left side.
For sure, because it's the more complicated side. Okay, so let's go. What do you want to do?
Expand the tangent.
Okay.
Theta.
So you're going to leave the cosine theta?
Yeah, just put that over 1 for now.
Very nice. That's what I like to do too, to make them both fractions, since we're turning 1 into a fraction. It just helps me remember where that cosine gets multiplied by. So what does tangent look like now?
That's sine over cosine theta, sine theta over cosine theta. And then for the sine in the denominator, it's be sine theta over 1.
If you want, we don't have a fraction in the denominator, so we don't necessarily have to make it a fraction, but you sure can if you want.
Okay.
Now I put an equal side, keeping the equal sign on the right side to remind me I'm working the left side, just so I kind of know, okay, I'm still on the left side. Okay, then what, Nicholas?
Cross simplify, like remove both of the cosines in the numerator and just be sine theta over 1, which would just be sine theta over sine theta. So
okay, so that gives me sine theta. And you're okay if you write it as sine theta over 1. You're also okay to just write that as sine theta over sine theta. Okay, so either way is okay. That's what that simplifies to. Okay, and then you said that equals
1.
1. So he did it. He did it. Excellent, Nicholas. Very nice. Okay, so with a little practice, we'll get more comfortable with these. And that's one of our biggest strategies, changing everything to sine and cosine and simplifying. I'll have you know, I did not learn that strategy until I was in college. I had a discrete math teacher who said, oh, just change everything to sine and cosine. And that wasn't a strategy I'd been taught in high school. And it often really, really helps. And so I was like, man, I wish I had known that sooner. Good strategy, good approach. Okay, and there is more than one way to work a problem. So there's always other approaches as well. Okay, so let's try 2 more. I think this is our last slide before I turn you loose on the test. Just a few more identities to practice, okay? So we've got cotangent x over cosecant x equals cosine x. Cotangent x over cosecant x equals cosine x. Anybody want to try this one? I know we haven't tried it yet. Like, there's no pressure. Like, if we don't get through, then, you know, we'll help each other. But anybody want to try it, okay?
Yeah,
Remember,
I don't know how to do it, but I'll try it.
Okay, you just helped me with the last one, Nicholas, so I'd like to see if anybody else wants to, but if not, I'll sure let you help me with it.
Can I try this?
Sure, Ananya, let's do it. Let's do it. What you got, Ananya? What do you see? What are you thinking?
So cotangent x is just cosine x divided by sine x.
Okay.
And cosecant x is 1 divided by sine x.
Perfect. Okay, so we're working the left side, trying to get it to equal the right side. Okay, was that helpful to us?
Because you could cancel out the sine x's.
Right, when the denominators are the same in a compound fraction, they cancel. That's right. So what does that leave us?
You are left with cosine x divided by 1, which is just cosine x is equal to cosine x.
She did it. She did it. Like a pro. Very nice, ma'am. Good job. Good job. Okay. All right. And our very last one here to try on the other side of the screen. Now, I put this one on here on purpose, and I want to give you a heads up before we even start. I created this one to create one where you're likely going to hit a point where you can't see how to simplify one side to get it equal to the other. Okay. So there's some difference of opinions about this. Okay, so I just kind of want to throw it out, the 2 ways that you may be required to work this. Okay, so when you get stuck on one side and you can't get to the other side, some professors will say it's okay to go ahead and work both sides as long as you're circumspect about the fact that you're not working across the equal sign, meaning you never multiply the whole equation by something, you never do that, okay? So if we can get the 2 sides equal to each other, that's okay. Other professors will require you to work backwards, meaning you go do a little scratch work where you do start working the other side until you can get it equal to the side that you're working. And then you just copy those statements in reverse order on the one side to keep it on one side all the way through. Does that make sense? Maybe, maybe not. Okay, let's start working on it and let's see what we got. Anybody want to get us started on this one? Anyone feel like they can get us started?
I can try.
Okay, let's do it, Nicholas. What you got?
So cotangent is cosine over sine x.
You're going to work the left side?
Yeah.
Okay, for me, looking at this one, I would think the right side looks more complicated because it's got more terms in it. So I would probably start on the right side, because what happens when you start on the simpler side is at some point you've got to blow it up and make it bigger. And there's a lot of things equal to 1, right? There's an infinite number of things equal to 1. So it's kind of hard to know how I want to blow it up bigger. That's why it's always easier to simplify smaller. And so that's why we usually recommend working the more complicated side. So can we try the right side first? And I've already told you we'll probably get stuck and need to work the left side too, but can we at least start trying on the right side?
Yeah.
Okay, so what could we do with the right side?
So expand all 3 of those trig terms.
Into sine and cosine?
Yeah, so
Okay.
it's going to be sine theta over cosine theta, and the cotangent would be cosine theta over sine theta, and the cosine theta would just be cosine theta over 1.
He's so fast, I can hardly keep up with him. Good job, sir. Okay. And what do you have done?
You can get rid of the first 2 terms. They both cancel out.
Okay.
Leave left with cosine theta.
Okay.
And then would you go to the other side now?
Yes, and this is what I mean. We hit a point where I'm like, okay, but how am I going to turn cosine into cotangent over sine? Like, how would I make it get bigger? I'm not really sure how. And so this is where we can either go on the side and start working the other side and then copy the steps in backwards. Or if we're, as long as we are circumspect about only working the left side, we can see if we can get them equal to each other. So let's try working the left side. What you got for me now?
All right, for cotangent, it'd be cosine theta over sine theta.
Uh-huh.
And then sine theta is just sine theta over 1.
Okay. And was that helpful?
Yeah, because you could get rid of both of the sine thetas.
Okay, they cancel. Uh-huh.
And
And that equals?
cosine theta.
Okay, it's cosine theta. Okay, so if you have a professor that's going to require you to only work one side, and we were working the right side, what I could come do now is I could copy the steps backwards. So here, if I wanted to state, so this, here at Champ, we'll accept this. You got them equal to each other. You didn't work across the equal sign, so you're okay. So we'll accept this. But if you had to do it the other way, then you would come and just copy those steps in reverse. You would then just write cosine theta over sine theta times sine theta over 1, okay? And then equals cotangent theta sine theta. Okay, so you literally would just copy the steps in reverse. Okay, so I copied this step, and then I copied that as my final step. If you wanted to, if you felt like it wasn't as clear going backwards, then what you could do in here is you could add an extra step that's just cosine theta times 1. And then I would probably add 2 extra steps just to really clarify if I wanted to, which equals cosine theta times sine theta over sine theta. Okay, because 1 equals sine theta over itself, right? And so then we have a cosine and a sine theta on top, and we have a sine theta and a 1 on bottom. So that equals this, which equals that, okay? So it might take a few more steps to make it crystal clear to people following your proof how that equals that, but that's what you would do if you had to work it on one side only, okay? The only reason people stress one approach or the other, David is here. He got here late, but he's here, so we'll change your attendance, sir. But is just to make sure that you're not trying to work with the assumption that they're equal until you've proved that they are in fact equal. Okay, any other questions in general for me before you guys get started on your test?
Yeah, I have.
Just one second. Emily's got a question in class, and then I'll take yours. Yes, as long as you don't mark across the equal sign, okay? But I mentioned that because this is the first school that I've worked at that is okay with that. Every other place I've worked at wants you working one side only, okay? So I just want to make sure that you know both, okay? Okay, and then what was your question? What were the topics we learned last class, because I couldn't find the meet recording? Yeah, Noah, so if you look at our Schoology folder, it'll show you exactly what we covered, and it'll have the files and or the links. So that was the Desmos, and so you just need to do the Desmos from last time we reviewed. So if you just go look in Schoology, you'll see everything that we did last time. Blank slides, and we just finished it today. So we just finished the review slides from last time today. So that's that same Pear Deck, and we just finished it up today. Okay, other questions for me?
Yeah, I have a question about number 1 from the study guide for my
Okay.
Can I present it quickly? Or
You want to just read it to me?
Yeah.
Okay, just one second. Let me start it in. Okay.
So it's sine 150 degrees. Sorry, not 105 degrees. My bad. Sorry.
Okay. And they just want you to find it?
Yeah, I don't know. You need to find the sum and difference formula that should be used to find.
Yeah, you're going to have to, because 105 isn't on the unit circle, right? So you've got to come up with 2 angles that add or subtract to make it. Did you find your 2 angles?
Yeah, I'm good on that part, but I had a lot of problems with the algebra for finding the exact value of it.
Okay, so what 2 angles did you pick?
45 and 60.
Okay, because we know it ends in a 5, so we're going to need a 45-degree angle, and then 60, so you added the 2. Okay.
Yeah.
All right, so that should be sine of the first, cosine of the second. When the words change, the sign stays the same, so it'll be plus cosine of the first, sine of the second. Did you do okay setting up your formula?
Yeah.
Okay, and so guys, right now we're in bonus time. Like we got through what I wanted to review for you. So if you feel good, you are starting your test, okay? And you're gonna have your test finished by the time you come to class next time. If you still have questions and wanna ask, stay with us. I'm happy to answer more questions. Okay, so sine and cosine of 45 are root 2 over 2. What's my cosine at 60, Nicholas?
It's 1 over 2.
Uh-huh. And you see me sketching it out. Like I just think about that angle. Its cosine is x coordinate 1/2. Its sine is root 3 over 2. Okay. And then when you multiplied that, what did you get?
Root 2 over 2. No, over 4, sorry.
Right. Good self-correction there. Okay. And then?
It's root 6 over 2.
Nope. Denominator times denominator is?
Sorry, 4. My bad. I did the same thing.
That's okay. So when we add or subtract fractions, we need a common denominator. When we're multiplying, we just multiply numerator times numerator and denominator times denominator. These are not like terms because they are not the same number under the radical, so they do not combine. So this is just root 2 plus root 6 over 4. Final answer.
Okay.
Okay.
Wait, maybe I wrote it down wrong.
Well, maybe you wrote it down wrong?
Yeah, because in the first time I did it,
Uh-huh.
I had to rationalize it, and I had a ton of problems trying to do that. Or maybe that was a different problem.
Yeah, I'm not sure, but I'm happy to look at any of them that you want to look at. Alex, did you have a question? Okay. Okay. Anybody else have questions?
Yeah, I'm confused with one on the study guide.
Okay, you want to read it to me, Sarah?
Yeah. Okay, so it asks to write the expression as the sine, cosine, or tangent of the angle.
Okay.
And it gave me sine of pi over 4. And then the cosine of 7 pi over 12. Plus the cosine of pi over 4. Times the sine of 7 pi over 12.
Okay, so remember, this is like what we said in class last time. This is giving you the right side of the formula. Did your algebra eyes start tingling? Did you recognize that as the right side of one of your sum and difference formulas?
No, I don't really know where to start with this.
Okay, so that's what this is. So part of it's just a little experience and a little practice. So take a look at your formula sheet, okay? And that is the right side of one of your formulas. Just where pi over 4 is your alpha, and 7 pi over 12 is your beta, your second angle. Probably need to switch colors there. So can you see that? When they give you the more complicated right side, they just want you to be able to recognize it and switch it back to the simpler left side, okay? So which formula is that the right side of? What would the left side of it be? Well, it starts with sine, so I know it's one of my sine formulas. And taking a look at your sine formulas, this is
plus beta.
Right, this is the sign of alpha plus beta. And you're right, because when the words change, the sign stays the same. So if that's a plus, this will be a plus, okay? And we would just need to plug in their alpha and their beta. So this would just be the sine of pi over 4 plus 7 pi over 12. And they would probably accept just that. I said yesterday in class, I would probably take it a step further and get that common denominator of 12 to see what angle we're actually finding the sine of. So I would probably multiply this by 3 over 3. That would be 3 pi over 12 plus 7 pi over 12, which is 10 pi over 12, which simplifies to sine of 5 pi over 6, which actually, we could actually find because 5 pi over 6 is on the unit circle. So 5 pi over 6 is right there. The sign is the y value, so that actually equals 1/2. But they didn't ask you to fully simplify it. They asked you to write it as a sine or cosine. So you could have probably stopped right there and just written it as sine of pi over 4 plus 7 pi over 12. It was about having you recognize the right side of the equation and know what it's equal to on the left side.
Okay, thank you.
Okay. Noah, can you read that problem to me?
Actually, for that problem, can you explain, like, from sine 5 pi over 6, how did you get the 1/2? I'm a little.
Okay, so 5 pi over 6 I recognized on the unit circle. So usually sum or difference formulas are when they're not on the unit circle. So then we have to get a sum or difference of two angles to create that angle. But as soon as it's simplified down to one that was actually on the unit circle, I'm like, I can find that myself. Sine is the y coordinate. So I went to 5 pi over 6 on the unit circle and grabbed its y coordinate.
Oh, okay.
I know.
Yeah, that makes sense.
Putting it all together, right?
Yeah.
Okay. So did you want to read me your question, Noah?
Yeah, it was pretty similar to this, but
So are you okay, or do you have another question?
no, I actually need to pull it up. I'm sorry.
Okay.
Okay, when I plugged the thing that you had in orange in, it said it was wrong and it needed me to take it the further step, but that was my last attempt.
So that's why I said this simplifies down to sine of 5 pi over 6. So it probably just wanted you to go ahead and get the actual angle there that you're finding the sine of. So did you try sine of 5 pi over 6?
I can't because that was my last attempt.
Your last attempt. Okay. So when I printed my key of the study guide with the answer key, it was just that second step of sine pi over 4 plus 7 pi over 12. I did text you guys. There was one, but it wasn't this one. It was a cosine one on the study guide that has the wrong answer key entered in. So
12.
yeah, on number 12 where it has you find sine, cosine, and tangent, the cosine answer is wrong keyed in there. So I'll be checking y'all's there to see that. Okay. All right. Any other content questions? Otherwise, I want to answer, like Haley has a question about her grade. So any other content questions before you guys start working on your test?
Yeah.
And so just a second, one more note to Sarah about that. So when I'm grading the test, because I told you guys that they're usually okay with just that first step, I'll take that. And that's where I hand grade on the test because it is worth so many more points. And so I would take an equivalent and you wouldn't have to stress about that, Sarah. Okay?
Okay, thank you.
Okay. Nicholas, what was your question?
Yeah, so the question I had about the algebra was on the next problem. Sorry. And that one was a tangent one.
Okay.
And I didn't know how to rationalize it the right way.
Just tell me what it is because I want to work it start to finish to make sure you didn't have a little mistake in the way that created the problem. Okay?
It's negative pi over 12.
Okay, and what two angles did you pick?
It gives you the angles, and they were pi over 4 and pi over 3.
Okay, and so did it give you the whole setup, or what? How much did it give you?
So yeah, we had to pick the right difference formula,
Okay.
and I picked
And so-
the one that had the negative on the top.
Okay.
And
So let me plug these in. So so if I double check this, so it gave you that. It just gave you the negative pi over 12.
yeah,
Okay. So let's check and see if these two are in fact the right one. So if I do my denominator at 12. I'm going to multiply this one by 3 over 3. So that's 3 pi over 12 minus, I multiply this one by 4 over 4, and that's 4 pi over 12. So that will give me tangent of negative pi over 12. So those are the good angles. So we're good to work. So we're starting with this tangent of pi over 4 minus pi over 3 and plugging it into the formula. The formula says tangent of the first minus tangent of the second because it's 1 plus, because it's the opposite symbol in the denominator, tangent of the first times tangent of the second. Okay, so did you pick that one so far?
yeah.
Okay, so then that's just going to be tangent minus tangent over 1 plus tangent times tangent. Okay, so what did you get for your tangent of pi over 4?
1 negative. Wait, I'm looking at my work from yesterday, so I'm not.
That's okay. Let's just work it together right now. To find the tangent of pi over 4, I go to pi over 4. Its x and y coordinates are both root 2 over 2.
Mhm.
So when I find my tangent, which is y over x, it's root 2 over 2 over root 2 over 2. Anything over itself is 1.
Okay.
So we should have gotten 1 for both of those. All right, then we want the tangent of pi over 3. So if I go to pi over 3, my coordinates are 1/2 and root 3 over 2. So tangent is y over x. So the tangent of pi over 3 is going to equal root 3 over 2 over 1/2. My denominators are the same, they cancel, so that's just root 3 over 1 or root 3. So I'm going to do root 3 in both. Okay, so this equals 1 minus root 3, and 1 plus root 3. And this is one where we're going to have to rationalize the denominator by multiplying by the conjugate. So are we all okay up to here?
Yeah, this is the part where I had a problem.
So when we multiply by the conjugate, we have the same first term, the same last term. One gets a plus and one gets a minus. So since this one already has a plus, I'm going to put a minus over there. Whatever I multiply the denominator by, I have to multiply the numerator by.
So it's always the opposite when you're rationalizing with like two terms.
That's what a conjugate is. So we're going to multiply by the conjugate, and the conjugate has the same first term and the same last term, and one of those has the plus and one of them has the minus.
Okay.
And we do that so that they end up being the difference of perfect squares, so that when we multiply them together, we get the first term squared and we get the last term squared, and it's the difference of perfect squares. And because we're squaring both the first and last term, we get rid of the radical. And that's why we did that. That's why we chose that as a strategy, because we knew it would get rid of the radical, okay? In the numerator, you've got to distribute because those aren't factors of difference of perfect squares. So we get 1, negative root 3, negative root 3, and positive, negative times negative is a positive 3. Okay, so that's going to equal, combining like terms, that's going to be 4 minus 2 root 3s over negative 2. And then, of course, every term in the entire fraction simplifies by a factor of 2. So, and I'm going to get to divide by the negative at the same time. So that'll become negative 2 plus root 3 over 1. So I'll just leave it as negative 2 plus root 3.
Okay. All right. Yeah, I think I got it. I didn't change the sign to the bottom.
Yeah. So a conjugate, yes, the conjugate is going to have the opposite sign as of the term that you're trying to get the conjugate for.
All right.
Okay. All right. Other questions?
Yeah, I found I found the question I wanted to ask.
Okay. And this will be my last one, then I'm going to take Haley's question on grades. Okay, Noah?
Okay, so sine parentheses pi minus theta inside the parentheses equals sine theta, and it says the identity.
Right.
Establish the identity.
And this one's a multiple choice one, right?
Yeah, it is.
Okay, so like we did problems like this in the examples yesterday, and we said you just do the part that you can do by hand, and then you leave the rest in terms of a variable, and you're not really worried about it. So sine pi minus theta equals, it's the difference of it's the sine of the difference of two angles. So that's going to equal sine of the first, cosine of the second. And when the words change, the sign stays the same. So it'll be minus cosine of the first, sine of the second. Okay. And then we know we can find the sine of pi, but we can't find the cosine of theta because we don't know what theta is. So it'll stay cosine theta. We can find the cosine of pi, but we can't find the sine of theta because we don't know what theta is. So when I substitute in the sine of pi, thinking about the unit circle, pi is right over here at 180. That's negative 1 comma 0. So the sine value is 0 and the cosine value is negative 1. Okay, 0 times anything is 0, so that whole term goes to 0. We've got negative 1 times sine theta. So this is negative sine theta, and then we've got minus sine theta. So we really have 0 minus negative sine theta. And 0 minus a negative makes a positive. That does, in fact, equal sine theta. Now, that's how many steps I would show if I was doing this by hand. They just went from this step to the final step. Okay, so I showed examples like that where they just went from the plugging into the formula equals the final, but I had us do the extra work to verify to ourselves that that is in fact true, that we can see why that would work.
Okay. And can you post the last day's Google Meet recording so I could just watch that?
I can. The answer key's already posted with all my work shown and everything, Noah. So did you try looking for my answer key? All right. I can. I'll have to go hunt it down, but I can. Okay.
Thank you, Ms.
All right.
Weaver. Have a good day.
You too, and good luck on your test, guys. Remember, the study guide is due by 11:59 tonight, and the test is due by next Tuesday at 11:59. Okay, so good luck working on your stuff. Okay, I want to take individual questions. So I'm going to just create a couple of breakout rooms so I can talk privately to people that had questions about their grades. So how many people are still with me that have a question about their grade that they needed to talk about? Nicholas, Haley, who else? Nicholas and Haley right now? Okay, then I'm going to go ahead and start breakout rooms for those two. If anybody else has a question, just pipe up. I'm happy to do a breakout room for you. No, you can ask for, well, yeah, let me check because I told them because they might be waiting for just that. So just remind me, Emily, if I forget, I'm happy to take more questions. And guys, I recommend that Nicholas and Haley, that you go ahead and start working on whatever else you're working on while you're waiting for me to pop into your breakout room so that you're not just wasting your time. Okay, I'm very conscious of your time.
Thank you, Ms. Weaver. Have a good weekend.